Okay, now let's talk about north and south circumpolar constellations. So North Circumpolar Constellation is a constellation that rotates around the North Celestial Pole. Remember the other day we were saying the sky rotates around the north like this, counterclockwise. And then if you're in the southern hemisphere, you're going to have a set of constellations that you can call South Celestial Constellation. And you're going to look towards the south, and they're going to rotate clockwise. So a South Circumpolar Constellation rotates around the South Celestial Pole, and it never rises or sets. So you have a north and you have a south. We live in LA, so we live above the Earth's equator. We do not have a South Circumpolar Constellation. We only have north. Okay? If you live in the southern hemisphere, you have South Circumpolar Constellation. Okay, so what we're going to do is illustrate this by different examples. So here are some examples to illustrate this and other concepts we have talked about before. So example 1, I'm going to take extreme situations here to begin with to illustrate this. Let's say you're living on the North Pole of the Earth. Of course, no one lives there, but let's say you go there and you are standing right on the North Pole. What's going to happen? What's going to be your situation? If you look straight up, you're going to see the star Polaris, the North Celestial Pole. Okay? So her zenith will be the North Celestial Pole. Her horizon line will be the celestial equator. So basically speaking then, we've drawn some of these things before, so just by way of reiteration, I'm drawing it again. So if you live in the North Pole, this is your zenith, North Celestial Pole. And then this is your horizon, like that. Okay? So now, we could also illustrate this with this picture. So if you're living in the North Pole here, we're using this as the semisphere to illustrate which part of the sky you see. So like that. This is your zenith. This is your horizon. See? Okay, remember what we were mentioning the other day, that the sphere rotates like this. 1 hour later it's like that. 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 24 hours later, what happens? If it began here, let's say this star began here, this star began here. 24 hours later, they come back. I'm going to put my finger there just to remember where it was. 24 hours later, it comes back, and it's a little bit ahead of itself, you see? And then 24 hours later, it comes back, it's a little ahead of itself. That's called the what motion? Starts with A, annual motion, right? So after a month, it'll be probably here at the same time. You see? So a month after that, it'll be here. A month after that, it'll be here. You see what's happening? So they're all going around, and they're all ahead of themselves. And then 1 month later, 1 month later, 1 month later. So 12 months later, they come back to wherever they were. Okay? So now, based on where you were, so if you're living in the north side, boom, this is gonna represent the half of the sky that you see. Okay? And now we can go to the notes, and then we can make more sense of this. She will only see the stars on the north celestial hemisphere. However, all the stars he or she sees will be north circumpolar for that person. So whoever is living there will only see the stars on the north celestial hemisphere. But whichever stars she sees, they will all be north circumpolar for her. What do we mean by that? So look at the rubber bands again. I'm going to face it this way so it can look a little better. Okay? Will she ever be able to see this star? No, it's always below her horizon, you see? This rubber band, through the course of the time, it's just going like that, you see? So this one, she never sees. This one down here, of course, she never sees. I can slide this up, and she never sees those. Okay, does she see these ones on the top? Oh yeah, these ones on the top, you see, they're above her horizon. Okay, in order to view the north celestial pole, she just looks straight up. So these ones are always visible for her. Okay, so we can kind of say this way. If you live on the North Pole, you only see half the sky throughout the course of the year. But those stars that you see, you can see them for the full duration of the year. Every evening that you go out, when it's nighttime, you get to see them. Let's see, what does this picture show? This is what the sky will look like if you live on the North Celestial Pole. Of course, they put a bear because there's going to be a polar bear there. So you're going to look up, and then the stars trail. They're going to go like this. You see? They're going to go like this. And then if you look straight up, you're going to see the North Celestial Pole. You're going to see Polaris. So if you have a long exposure camera, and you take a picture of the stars throughout the course of like 1 hour, they will leave a trail like this in 1 hour. People do that, like photographers, they love taking these pictures. They take a long exposure camera. The camera opens the shutters and it stays there for a while. And then you can take a star trail like that. So if you're in the North Pole, that's the kind of picture you'll see. Now in the equator, that's the other extreme. Let's see what happens in the equator. If a person lives on the Earth's equator, so now what happens? The picture changes. So this was the case in the North Pole, and now the equator. Now the sky that you see is this part. So you see this part, and then you don't see this here. So if you look straight up, you see this is the celestial equator. And then this is your horizon. It goes like that. So this is the part of the sky that you see. Okay? So again, it's good to visualize it like this. Smack dab like that. Okay? Oops. Your half of the sky fell. Okay. So throughout the course of the year, these things are going like this. You see. So throughout the course of the day, and then throughout the course of the year, what's happening? Okay. So in 1 hour later, 1 hour later, 1 hour later, you know. So basically, the stars are rising from one side, and then they're going across. It's going to take them 12 hours. Okay, no matter where the star is, you see, it's going to take them 12 hours to travel the full duration. So if the rubber band starts out here, and then 12 hours later, they're going to end up here, okay, like that. And then after that, they're going to go below your horizon. So during the course of the day, you'll have 12 hours access to a star, and then the other 12 hours, they're going to be below your horizon. How about throughout the course of the year? How many months do you have to view any star? Okay? So if you have like that, if a star starts out here, 1 month later, it's there. 1 month later, it's there. 1 month later, 2 months, 3 months, 4 months, 5 months, and then 6 months later, it's here. You see, I'm looking at this rubber band here. So you basically have 6 months access to any star. Because the other 6 months, it's below here. Okay? So if a person lives on the Earth's equator, let's see what this picture shows. Okay, if you live on the Earth's equator and you had a long exposure camera, the path of the star trails is much different. They rise and then they go like that. Okay, they don't go like this. You see? So it's basically vertical. It just goes straight up. And then it goes like that. You see? So her zenith will be the celestial equator right there. Her horizon line will be the vertical line from the North Pole to the South Pole. They will barely be able to see the Polaris. Polaris will be at their horizon. Imagine there's a star here, star A. Imagine there's a star here, star B, star C, star D. And then they're doing this, right? So tonight, if that person goes out and looks at the sky, which of these stars does she see? C and D. She doesn't see A and B. Okay? I'm talking about, let's say this is the case tonight at 10 p.m. Right? Tonight at 10 p.m. And then tomorrow at 10 p.m. where it's going to be a little bit ahead. This one's going to be a little bit here. Okay? 1 month later at 10 p.m. so we can draw a circle like this. One month later, star A will be here. Star C will be here. She can still see C and A, but she can't see A. So she can see C, A, it's still below her horizon. It's down here. D will be here. B will be there. See, they'll rotate like that. So 1 month later, she still can't see D. 2 months later, 3 months later, something like over here. And then B will be over there. So now it's getting hard to see D. Now B is starting to come up. You see? Now the whole thing takes exactly 12 months. So 6 months later, D will be here. They will exchange positions. B will be here. D will be over here. B will be over there. So 6 months later, the opposite case will happen. She will be able to see B. She will be able to see A. A will switch over here. C will switch over here. So how many months overall does she have to view any particular of them? Well, if this whole thing from here to here was 6 months, from here to here is roughly 3 months. From here to here, 3 months. From here to here, 3 months. From here to here, 3 months, and then back. Okay? So 3 months, 3 months, 6 months she has to view a star. This one, 3 months, 3 months. This guy, 3 months, 3 months. Okay? So any star, she basically has 6 months access to that star at night. Now you might say, okay, so big deal. What's so important about that? Well, basically the conclusion out of that is this. If you're an astronomer, and let's say you want to go out at night and you want to study only the stars of the northern hemisphere, you want to be able to go out at night, every single night, focus on a star in the northern hemisphere, and you want to be able to see that star. Where would you have to put your observatory, your telescope, if you're only interested in the northern sky? Put your telescope on the North Pole, as close to the North Pole as possible. Okay? If you put it at close to North Pole, you will have 12 months access to the stars of the northern hemisphere, right? And you'll be able to view them at any night time. If you're an astronomer that's more interested in viewing the whole sky, you don't care that you will only be able to see 6 months at a time. You'll be able to study the stars of the north sky 6 months, stars of the southern sky 6 months. Where would you put your telescope? Equator, yeah. Now you have full access to the whole sky, but you only have it for half the year. You see the difference? Okay, now what happens? So for the person on the equator, is there such a thing as a circumpolar star that she can go out and see at any night? No, there isn't. Now what happens at mid-latitudes? If you live at a latitude of 60, then your zenith will be the horizontal line across the celestial sphere whose deck is 60. His horizon line will be the horizontal line whose deck is negative 30. She will see stars, only the stars above the horizon line. So basically, I'm just putting all this up at once. So if you live on the So let's say you live over here. This is 60. Imagine this angle is 60. So you make a like this. This is the part of the sky that you see. Okay, so this star, it's going to go like this through the course of the year. Are you always going to be able to see that star? Yeah, it's always above your horizon. How about this star? It's going to go like that through the course of the year. Are you always going to be able to see that star? Yes. How about this star? It's going to go like that through the course of the year. Are you always going to be able to see that star? No. Whenever it's doing this or this, whenever it's here, you can't see it. But you can see it for most of the year, about 10 months of the year. You see? 10 months of the year. How about if a star is right in the celestial equator? If a star is celestial equator, how many months can you see it? 6 months you can see it, 6 months you can't see it. How about if a star is here? Ooh, you might not be able to see it at all. How about here? Of course you won't be able to see it at all. How about here? Can you see that star ever? Yeah, maybe you can see it for 3 months. 3 months of the year, 4 months of the year, 8 months you can't see it. You see? So basically what I'm illustrating there with the rubber band, you can illustrate on the board. So same thing, whichever way is easier for you to visualize. If you're living on a 60, it's like this. Okay? It's like that. So this star you will probably never see. As I rotate, see, as I rotate like that, this rubber band will never come up beyond that. This guy you will see for 6 months, this rubber band. This guy over here you will always be able to see. Okay? Like that. It's a little hard to rotate this, but anything down here you will not be able to see. So what's the conclusion? Which ones won't you be able to see? You can make a little geometry. You can say, well, if this is 60 degrees, then this is 30 degrees. This little piece is 30 because this is a 90-degree angle. And therefore, this is also 60. Okay? Anything below negative 30, this is a negative 30. So anything 60 degrees from the south celestial pole, you will not be able to see. Anything 60 degrees. So this is what this is saying. Any star within 60 degrees of the north celestial pole will be north circumpolar. Any star, you see here, she will all see the stars above the horizon line. He will not be able to see any stars within 60 degrees of the south celestial pole, within 60. So what does that mean? Anything 60 degrees out the south, you see all of these guys here, they will not be able to see that. And then anything 60 degrees from the north celestial pole, basically you can, if you want to do a flat version of this, you can go like this. And then you can say, okay, if the person is living at 60 degrees, you can make like this. This is the easy way to remember it. If a person is living at 60, this is 60 and this is 60. So it's the same latitude as wherever you're living. So I would say remember it this way. If you're living at 60, anything 60 from the north, go down 60. This part of the sky you will be able to see for 12 months of the year. They're north circumpolar. North circumpolar. Anything 60 from the bottom, you will never be able to see. This is kind of the flat version of this. Okay, so there's many different ways of visualizing it. The globe way, there's the flat, there's this way, a circular way, and there's this way. So you can say, If you're living at a 60, and where's that? 60 is kind of like New York City or Toronto, something like that. Anything 60 from the north, north circumpolar. Anything 60 from the south, you would never see. This part of the sky, you see depending on where it is. So this part of the sky, close to this part, like this part here, you'll probably be able to see 11 months of the year. You see, the ones that are up here, you see how most of the year you will be able to see it, but little portion you will not be able to see it. So as you go down, you'll be able to see these guys 11 months of the year. If you go down a little bit more, you'll be able to see them 10 months of the year. And then when you get down to the equator, you'll be able to see the equator for 6 months of the year. So you go 11, 10, 9, it quickly goes down. 11, 10, 9, 8, 7, 6, there's no space to write it. By the time you get to the equator, you see the equator for 6 months of the year. Then it goes 5, 4, 3, 2, 1, and then this one you'll never see. It's like almost like a widescreen TV, you know, closes in, and you only see this part of the sky, okay? How about when you live down in LA? LA is more like 30 degrees. Okay, with LA, you have, if a person lives at a latitude of 30, then her zenith will be the horizontal line across the celestial sphere whose deck is 30. Her horizon line will be the horizontal line whose deck is negative 60. This is the one that I gave you the chart for, the flat map, okay? So now we can turn that on. So you see this is Z here. This is kind of for us. Okay, so then so what's the case? She will not be able to see any star within 30 degrees of the south celestial pole. All the stars within 30 of the north celestial pole will be north circumpolar. Okay? So notice, how do you remember it? It's easy because it's the same as your latitude. If you live at 30, anything 30 from the south you can't see. Anything from the north you can always see. So how are we going to make that widescreen TV? We're going to go up here. Anything 30 from the north, 20, 30, basically 34. If I want to do it for LA, I got to go down 34, a little bit more than 30. So I'm going to go down 10, 20, 30, 34. I'm going to draw a line here. Then I'm going to say always see. So these are our north circumpolar constellations. Okay? Which ones do we never see? Start from the bottom and go up 34 degrees. Okay? So our bottom is here, 10, 20, 30, 34. Well, that takes you to the horizon line. Never see. Okay, so about these stars, how many months do we see them? 11 months. These stars, 10 months. Then you start going down 9, 8, 7. By the time you get to the celestial equator, how many months do you see them? 6 months of the year. 5, 4, 3, 2, 1, never see. Get the idea? These ones always see. Okay? Again, if you want to look at it this way, this is the situation where it looks like LA, more like that. LA is a latitude of 30. So you go like that, you go like that, you will see. This part here is like a cone. That's the part that I'm drawing there, the north circumpolar one. And then this part down here, there's a little cone. You never see these guys, you see? So this is the actual way to visualize it. but the flat map makes out everything flattened out, you see. So what I did one time is I went through the constellation list because I was interested to see what this means. Remember the constellation list that we looked at? And then I looked at their deck angle in particular. I looked at their deck angle, and I wanted to see which stars whose deck angle was within 30 degrees of the south celestial pole. Okay, so that means anything like -80, -70, -60. Those would be the constellations that from LA you could never see. Because what I want to always do is say, when I learn something, I want to say, what does that mean to me? How does that apply to me? Otherwise, I'm just learning things just to learn them, you know. So I took a number of those and I counted them. Then I looked at the ones whose angle is 30 degrees from the north. So anything like 80, 70, 60, down to 56. Okay, so look at how I counted them. I put an X next to the one that is very negative. The constellation Apus, X. Its deck angle is -75. Then I put a check mark next to one like Camelopardalis, +70. We always see that from LA. Then I went and I put Carina, I put an X, -60. You can never see from LA. Cassiopeia, +60. You can always see. +70. You can always see. Camelopardalis, Circumpolar, -80, -60. You cannot see from LA. And then you can keep compiling that list. There are more that we cannot see than the ones that we can always see for LA. Look at this. Mensa, Musca, Octans. -80, -7, -85, -60, -65, -65, +70, Ursa Minor. Ursa Major is one of those that we can mostly see, but there are some months that you're not going to be able to see it. Look at Ursa Major, +50. It's a little bit below our north circumpolar, because for us, north circumpolar, you got to be above 56. So it's a little bit below. So I'm going to say the Big Bear, you can probably see 11 months of the year. But 1 month, you're not going to be able to see it. And then there's -70. So after I counted them, here's what the conclusion was. I counted 5 that you can always see from LA. 5 constellations. Always see. Then I counted 15 that we can't see. Deck angle less than -56. So which 5 are the north circumpolar ones? Then I went to this chart because this shows you the north region of the sky. Here's what I did. I went 10 degrees, 20 degrees, 30 degrees, 34 degrees, and I drew a circle. Remember that I said it's like a cone? And I tried to look inside of there. I should be able to find 5 constellations inside of that cone. 5. And I did find the 5. It's there. Okay? So here is one of them. Of course, the one that we mentioned, Ursa Minor. That's Ursa Minor. And then there is Draco right here. I'm not going to draw all of them, but it's kind of like here. It's the dragon. Okay, that's Draco. So there's 1, 2. There, you see here, Ursa Major is falling. Part of Ursa Major is falling below. So it's not one of the 5. Okay. Then if you go over here, there's Camelopardalis. Okay. And then if you go rotate more, I'm just going to rotate them. So you can see the next one, Cassiopeia. Then you can see the next one. Cepheus, Draco, okay, so you're going to have overall then Camelopardalis, Cassiopeia, Cepheus, Draco, that's 4, and then Ursa Minor, 5. Okay, so I should be able to tell you tonight, go and see, try to see all 5 of them. You should be able to see them. Look north, go up, 34 degrees, that's Polaris. There's Ursa Minor, and then all of them are going to be rotating around that. It's like a cone. 34 degrees, 34 degrees. 34 degrees, look sideways. 34 degrees that way, 34 degrees here. Okay? So it's going to go like that. And you can go August, July, September, November, any month of the year, you should be able to see all 5 of those. You see? So the upshot of all of this, the summary is that as you move from the North Pole of the Earth to the equator, you see more stars through the course of the year, but less of them are circumpolar for you.